Alright, so we looked at the graphs. Now we're going to look at the domains and ranges of these curves. So the sine curve, we talked about this the other day, has a domain of negative infinity to positive infinity, and the range is from -1 to +1 inclusive. So when we look at our sine curve, and we looked at the calculator also to confirm this curve continues forever, and it only reaches as high as +1 and as low as -1. So our domain is negative infinity to positive infinity, and range is -1 to +1. The same thing is true for cosine. So here's our cosine curve, right? And that goes on forever also. So our domain is negative infinity to positive infinity, and our range is -1 to +1. So now when it comes to our tangent and these other curves, they all have asymptotes. So when we look at our tangent curve, notice that we have an asymptote at -pi/2, pi/2. We would also have one at 3pi/2. So every increment of pi/2, we have an asymptote. So we write that as all real numbers except n pi/2, where n is odd. So that means 1 pi/2, 3 pi/2, 5 pi/2. So n has to be an odd number. Our range is going to be negative infinity to positive infinity because it goes on forever. Okay, so cosecant. So our domain again. So for our cosecant curve, we have asymptotes at pi, 2 pi, 0, and -pi. So for cosecant, it's all real numbers except n times pi, where n is an integer. So when we talk about the range for the cosecant, notice that the curve doesn't exist between -1 and +1. So the curve is only +1 and greater and -1 below. So we say that it goes from negative infinity to -1 with a union of 1 to infinity. And the same thing's going to happen with our secant curve. So with the secant curve, though, our asymptotes are again at -pi/2, pi/2, and 3pi/2. So again, n pi/2, where n is an odd number. So that's our domain for the secant. All real numbers except n pi/2, where n is odd. Okay, and our last one, our cotangent curve. So the cotangent curve, again, we have asymptotes at all of our increments of pi. So our domain is going to be all real numbers except for n times pi, where n is an integer. Our range is going to be negative infinity to positive infinity. So when we're talking about this next section in our chart, we've talked about the period in class sum. So the period is how often things are repeating. So for the sine, cosine, secant, and cosecant curve, the the period is going to be 2 pi. Now we're going to introduce another value called b, and our period is going to be affected by b. So if I take that sine curve that I created earlier on my calculator, and so I have sine x, and if I graph that, you'll notice that my curve, the way that it's set up, I have that there. And I'm going to change my window just a little bit. I'm going to put x-min at 0. So now all I'm seeing is one complete period of the sine curve. So if I put a 2 in front of that, if I make it sine of 2x instead of just sine of x, what happens is, notice that I now have a complete sine curve right here, and I have another complete sine curve. So I basically have taken that sine curve and I have compacted it, and I've created more functions or more periods in one length of time. So what we're going to talk about is how to adjust the periods of these functions. The amplitude is how high the graph goes or how low the graph goes. So it's +1 to -1. The phase shift is, like we did with other curves, the ability to go left and right. So left to right. And to find our phase shift, since this is a -c, our phase shift means that we're going to be shifting it positive. So this is saying the opposite of the value of c divided by b, so it's going to be a positive move in this case, depending on what you have. C divided by b tells me my phase shift. And then for sine, there's no asymptote. Cosine, there's no asymptote. We already talked about the cosecant has an asymptote at n pi, where n is an integer. Secant has an asymptote at n pi over 2, where n is odd. And all of these are dealing with a period of 2 pi. So we're going to do some examples of those in a minute. Okay. Now the tangent and cotangent both had periods of pi. So the period of tangent is pi divided by b, and cotangent is pi divided by b. Technically there's no amplitude for the tangents because they go on to infinity. Sometimes people will still say the amplitude is the absolute value of a, and that just sort of tells you what point you're going to use for that pi over 4 value. And again, my phase shift is -c divided by b, and my asymptotes, as we discussed earlier, for tangent, it's n pi divided by 2, n is odd, and cotangent, it's n pi, where n is an integer. Now the value of d in all of these, d affects my vertical shift. Okay, so that will shift our graph up and down. All right. So let's look at some examples of a couple of these problems with our shifts in there. Sorry. Okay, so here's an example of some problems. Let's look at these. So on this one, my amplitude is going to be 1/2. On this one, my amplitude is going to be 4. On this one, my amplitude is 2. And here, my amplitude is 2. Now, I forgot to put an example on here of a negative. So let's assume that this one's negative. So let's say it's -2 cosine 3 theta. So then we would still say the amplitude is 2. But this negative in front would cause the graph to change directions. It would be flipping it over the x-axis. Okay, so let's go back and look at our periods here. So the sine normally has a period of 2 pi. So to find the period of this function, we're going to take 2 pi divided by b. This is b. So it's going to be 2 pi divided by 3. So that's my new period. And we'll talk about how to deal with that in a second. On this one, my period is going to be 2 pi divided by 2, which is pi. On this one, the number in front of theta, b, is 1/3. So I'm going to have 2 pi divided by 1/3, which is the same thing as saying 2 pi over 1 over 1/3. Multiply the outside to the inside, so I get 6 pi is my period. On this one, again, my period's going to be 2 pi divided by 3, so that's my period. So how does that affect my graph? So remember I told you we're always going to start our graph from 0, and this is what we're going to do. So if, I'm going to take this one because it's a little bit easier to start with. So we're going to start with this. So my period is pi. So I need to mark off the halfway point. Okay, so this is going to be pi divided by 2. And then I need to mark the halfway point here. So that's half of this, which is pi divided by 4. And now I'm going to count by 1/4. 1/4, 2/4, 3/4. So my missing point here is 3 pi over 4. My amplitude is 4, so that means that I'm going to have it going from 4 to -4. This is a sine curve, so sine starts at 0, goes up to 1, or in this case 4, back down to 0, back down to -4, and back down to 0. So there's my sine curve. So this is the same problem almost that we did on this graph. So notice what happened is on the graph you can see the difference when you compare the two. On this, all I'm looking at is the x-axis and how you've labeled your values there. So when I put a 4 in front of the second term, and I'm going to have to go to my window and adjust it slightly. Now when I graph my curve, there's my original curve. And here's my new curve. Notice that's much steeper than the other one because of the amplitude of 4. And also notice how I have one complete curve for each hump of the original curve because I've shrunk it down. Okay, so we'll look at some more examples in a minute.